The question of the day is, given that AI belongs to the set S where S is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and alpha is equals to 2 raised to the power A2 plus 3 raised to the power A3 plus 5 raised to the power A5 plus 7 raised to the power A7 plus 9 raised to the power A9 is divisible by 4, then find the maximum possible number of A2, A3, A5, A7, A9. Pause the video if you want to give this question a try and then resume the video when you want to check out the solution. Alright, so now let us get started with the solution. So first of all, we observe that alpha has all odd terms except for one, and that is 2 raised to the power A2. Now we will consider three cases. Case number 1, and that is when A2 is equals to 0. Case number 2, and that will be when A2 is equals to even, and that is A2 is either 2, 4, 6 or 8. And then case number 3, and that will be when A2 is equals to odd, and that is A2 will belonging to 1, 3, 5, 7 or 9. So now first of all, let us get started with case number 1. Now for case number 1, A2 is equals to 0, and that will imply that this quantity will now becomes equals to 1. So alpha will be equals to 1 raised to the power. When 3 is divided by 4, it will leave a remainder of minus 1. So minus 1 raised to the power A3 plus 1 raised to the power A5 plus minus 1 raised to the power A7 plus 1 raised to the power A9. Now whatever may be the values of A3, A5, A7 and A9, this expression can neither become equals to 0 nor it can become equals to 4, and hence alpha in this case will not be divisible by the quantity 4, and hence for case number 1 the answer will be equals to 0. Okay, now let us move on to case number 2. Now for case number 2, 2 raised to the power A2 will always be divisible by 4, and now the only question is whether this quantity will be divisible by 4 or not. Now this quantity will either give sum equals to 0 for this to be divisible by 4, or it will give sum equals to 4 for alpha to be divisible by 4. Now let us consider the case when sum equals to 0 in the first place. Now sum equals to 0 will only happen when this quantity will become minus 1, this quantity will become minus 1, and these two negative ones will get cancelled by these two positive of ones. So now A5 and A9 can belong to the set S, because irrespective whether A5 or A9 is positive or negative, this expression will always amount to be equals to 1. Similarly, this expression will always be equals to 1. But as far as A3 and A7 are concerned, they have to be equals to odd, that is 1, 3, 5, 7 or 9. So we observe that there are 5 ways in which A3 can be selected, 5 ways of selection of A7, 10 ways of selection of A5 and 10 ways of selection of A9. So writing this, we get 5 into 5 into 10 into 10. So this will be equals to 2500. And similarly, for S is equals to 4, we have that A5 and A9 can belong to the set S, whereas A3 and A7 must now necessarily be even, that is either 0, 2, 4, 6 or 8, and hence again for A3 there are 5 number of choices, for A7 there are 5 number of choices, for A5 and A9 there are 10 number of choices each. So this will be again equals to 2500. Adding these two cases, this will be 5000, and for A2 there are 4 possible ways. So 4 into 5000 will amount to 20,000. So we have 20,000 number of cases in case number 2. So now let us move on to case number 3. For case number 3, A2 is equals to either 1, 3, 5, 7 or 9, which simply implies that when 2 raised to the power A2 is divided by 4, it will leave a remainder of 2. So now the only possibility for which alpha is divisible by 4 is that we should get a remainder of 2 from this expression when divided by 4, and hence this is only possible when either of A3 or A5 is odd and the other one is even, because in that case what will happen is this quantity will always give a remainder of 1, this quantity will always give a remainder of 1, so A5 and A9 can belong to the set S. So there are 10 ways of selection of A5 and 10 ways of selection of A9. Now let us consider the case when A3 is odd. So A3 belongs to 1, 3, 5, 7 and 9, and A7 is even. So A7 will belong to 0, 2, 4, 6 and 8. So there are 5 number of ways in which A3 can be selected and 5 number of ways in which A7 can be selected. So this will be 5 into 5 into 10 into 10, 10 each for A5 and A9. So this will be 2500 number of cases, but then again these all cases will have to be multiplied by 2 because these two cases can be interchanged. So 2500 into 2 will give us 5000. So there are 5000 number of ways by which A3, A5, A7 and A9 can be selected, but then again A2 can be selected in 5 number of ways. So this 5 when multiplied by this 5000 will give us 25,000, and hence there are 25,000 number of ways for case number 3, and hence to summarize, there will be 0 plus 20,000 plus 25,000 number of ways in which these variables can be selected, and hence the answer to our question will be 45,000, and that is the answer to our question. I hope you have understood everything taught in this video. Thank you.